I want to talk about confusion matrix in this video. Confusion matrix is used to measure performance of classification models. So we basically use the confusion matrix to derive some metrics, and those metrics will be used to measure the performance of classification models. So before looking at those metrics, we want to understand how confusion matrix works. So in this video, the focus is just on the confusion matrix. We'll be understanding what is confusion matrix, and we won't be looking at any of the metrics that can be derived from confusion matrix in this video. Now, in order to explain this confusion matrix, I'm going to use binary classification as an example. But confusion matrix is not just limited to binary classification. It can be used for multi-class classifications as well. But just for the sake of simplicity, I'm going to use binary classification to explain confusion matrix. Okay? Now, in binary classification, obviously, we'll have two classes. Let's call the first class as C1, and let's also assume that it is a positive class. And the second class is called C2. Let's assume this as a negative class. So imagine that this is some sort of COVID classification. So you want to decide whether someone is COVID positive or not. So if it is positive, they'll be in class 1. If it is negative, then they'll be in class 2. So this is some general terminology that we will use in binary classification. And these terminologies are important because we will be using this in the context of confusion matrix as well. Okay, so it doesn't have to be like this actually. So we can have C2 as positive and C1 as negative as well. It doesn't matter. But in general, we'll pick one of the classes positive class and the other one will be the negative class. Okay. Now, when a model predicts this class, it could be correct or it could be incorrect as well. So it could be really positive or it could be incorrect as well. And the same is true for negative case as well. It could predict the negative case correctly or incorrectly, right? So now the combination of these two is creating 4 different possibilities now, right? So a positive is predicted correctly or incorrectly, and negative is predicted correctly or incorrectly. So these 4 combinations, if we put them in a matrix form, then that is what is called as confusion matrix. So this is an example of confusion matrix. And the reason why we call this as confusion matrix is because we have cases that are confused by the prediction model that we have. That is why we call this as a confusion matrix. Okay. Now looking at this, if we translate these 4 options in the matrix here, on the y-axis we have predicted values, and on the x-axis we have actual, which is the real value basically. Okay. So if the model has predicted something as positive and it is in fact positive in reality, then we call that as true positive. If the model has predicted something as positive, but in reality that is negative, then we call that as false positive, because the model has predicted it as positive, but which is false, right? So that is why we call it as false positive. And then again, if model has predicted something as negative, but in reality, if that is positive, then we call that as false negative, because this was predicted incorrectly as negative. So this is called false negative. And finally, we have true negative, which is where a model has predicted something as negative and in reality also that is negative. So this covers all these 4 combinations that we have seen here. Okay. So this is what we call as confusion matrix. We put this true positive, true negative, false positive and false negative into this matrix like table, and this table is called confusion matrix. Okay. And when we are developing model, our aim is to increase the true positive and true negative, because that is the correct predictions, right? We want to maximize those two, and we want to minimize the false positive and false negative. So this will be the aim for any model that we will develop. Okay. Now, like I said, this confusion matrix is not just for binary classification. It can be used for multi-class classifications as well. So as an example, if we take the confusion matrix for 3 classes A, B and C, this is how it will look like. So we have true positive for A, true positive for B and true positive for C, and then we have true negative for all the other combinations. Okay, so we can have this type of matrix for any number of classes. So this is an example again for 3 class confusion matrix. Okay, so like I said, we can use this confusion matrix to derive some metrics, and those metrics can be used to measure the performance of classification model. But I'm not going to talk about them in this video. I'll be covering them in the later videos. And this is all I wanted to cover in this video. I hope this is useful. Thank you.